everyone, and welcome to BNB Chain's 2024 Q3 Hackathon workshop day 6. Today we are hearing from 4 people. So the first will be with Andre from Hackathon. He is a tech architect, and he will be discussing and addressing poisoning attack detector. Next up, we will be hearing from Antonio, who is the COO of Polyhedra, to hear about ZK Light Client for BSC. Next up will be stablecoins and TUSD with Astro, who is a community manager at TUSD, and we will be finishing up with how to use attestation for different tracks from Phoebe, who is community lead of BAS. So, Andre, over to you.
Yep, thank you so much. Let me start. So the topic of my presentation will be talk about address poisoning attack detection. What is it? How attacker use such approach? What kind of options we can have to prevent it? How to develop a detector based on hacking tools? And okay, let's start. And first of all, let me introduce myself. I'm an architect at Hackathon. One of the parts of my work is to work with Sentinel SDK. We will talk about it today more. What is it and how to use it for attack detection. The agenda for the talk is 3 parts. The first one talk about the introduction to address poisoning attacks and to our components tooling, which we are using at Hackathon, and for Sentinel SDK and extractor system. Okay, let's start from address poisoning attack. What is it and how it's possible and what is behind of this attack? The fact is that this attack rely on human mistakes. The user copy-paste address from the history from his transactions, and due to the complex address length and the address is long and complex, that's very easy to make mistakes and copy a wrong address. And that's the idea of attacker, just to make confuse person attacker by this attack. And example, how it looks like. You see on the screen there is a 2-2 transaction, and the numbers is pretty similar. And just because of Explorer make the address more shorter, it's very difficult to distinguish which of them are correct one and which are phishing address or similar address used by attacker. And just to understand it, how it's work, there is a five steps. The first step, when phisher find the victim, that's monitor all transaction through the Ethereum network. And the second step is try to generate the very similar address related to similar to victim address. And when such address is founded and created, the next step is attackers send a lot of small amount transaction to victim address, just to flood this transaction history. And as a result, the person just make a copy of the wrong address and send funds to wrong address. It's not just legal one, not legal, but that's correct one, or attacker control it. And that's a situation when attack can be successful. So the pretty simple logic very based on the amount of transaction, very difficult to track. And why such kind of attack can be effective? Just because, as we saw before on the screen, the Explorer or wallet make complex address shorter, just for more user-friendly, or just to keep easy to read by person. And it's a situation when we have many transactions in our wallet or in the list of transactions. That's very difficult to by human, very difficult to realize which of them is correct one, which of them is phishing address. And again, the main goal to make a person make a person to make mistakes. That's a main goal, and that's why it's working. What we can do to mitigate such kind of attacks, we need to be cautious with this small transaction. Always need to check and verify address, but based on the fact that such number of transaction can be a lot of, it could be difficult, because each address, before we are sending or operating, we need to verify it with a proper one. More automated way is to use labels provided by wallets, but also that's required for human attention to track all of them and to map them to and do it on daily basis, on continuous process, or use Ethereum name service to map the addresses to human readable format. What kind of limitations on human mitigation action? We are prone to human error, again, just because of a lot of number of transactions. That it's really difficult to be consistent for tracking before doing any operation. Verification of address is time consuming. In case of large number of transaction addresses, it could be really annoying. And just because of the different scenarios of attacks, possible attacks, it's the similar address could be really close, and that's need to be very careful with these checks. Over the time, we can believe that we are not we are unsafe, but that's how it can be used. So that's our feeling that we are unsafe can play bad thing with us, and plus all the attack can migrate, or not migrate, but change over the time, and user need to be track what happened, what kind of new attacks is raised, and that's bring more complexity of using transaction and sending transaction, right? So, and quick recap: major root cause for attack, the complexity of address which we use, and human error. What we can do to solving that's if attacker use automation process and monitoring system generation system, we from defending side, we can develop and use the detectors which help us to identify if we are under attack, to improve our awareness of the situation. Are we in safe place? Should we keep more careful? And and create conditions to attacker is which difficult to attack with such kind of address pointing attack. That's the reason why as a part of BNC chain challenge, we create from hacking, we create the options which you can apply for address pointing attack, develop address point attack detector. We describe here the requirements for attack detection, because options for detection can be many. And then the next step is what we can do, how we can develop detectors. And at Hacking, we believe that's open community and tooling and open source for detection, for prevention of attack, can help us to be in safe place. And that's two tools. Sentinel Python SDK is available on GitHub. That's Apache license SDK, which can be used for developing process of monitoring and detection. And Extractor is a monitoring system with very powerful tools for monitoring, configuration, detector, notification user with different channel, and many pre-configured detectors which developed and supported by Hacking. Okay, let's start with Sentinel Python SDK and how we can use it for attack detection. Detector SDK or was developed inside of Hacking just for our own needs, but then we realized that it could be useful for other people as well. That's how we can make contribution to, as I mentioned before, in to community. Then because it helps perform research and prototyping different attack, not just address poisoning. That's even for address poisoning, we can play with different method. We can play with simulate with them, understand what is working, what is not working. We can activate just feature which interesting just for us. There is no need to wait when someone develop a feature in own system and you can use it. If you have enough skills, but for that's you can develop. And our main goal to make Sentinel SDK as simple as possible. That's people concentrate more on working with detection, attack detection, or data processing, then think about how to deploy it, how to integrate it, and how to consume. And that's as a continuous, what kind of problems Detector SDK solve. So simplify research, and development. So make quick POC, just to make proof of concept. That's the approach which we would like to implement and test can be implemented quickly. So the idea is the attacker has more time for preparing for attack, and for defenders usually has less time, because if attack started, prepared attack, you have much less time for implementation. And that's the idea. So the tool should be as simple as possible in use for just to prevent or just to collect information and so on. As a part of Hacking infrastructure, we and I will discuss later that we simplify the data sources which needed for working with attack detection by unifying data sources and format. The SDK support different data channels like streaming, batch processing, or scheduler processing when we need to periodically run short-term runs. Again, the simulation, then as a part of research stuff. And environment agnostic means that if we develop something that is working on our local machine, it should be working in the same way on in cloud or in any environment. It doesn't really matter. In simple way, one detector is enough. But in real life, we need more detector to track different scenarios. Like we need to find, as a part of address poisoning, we need to find similar address against our monitored addresses. Or we need to track and enrich our suspicious address account contracts, and collection about all possible ways how we can be attacked. And that's the situation. So it means we can run multiple different detectors which can cooperate with each other by enriching databases, by collecting the information which we can reuse from in another detector. So that's a point. Reusable solution and collaboration. That's what we believe is really important. Then when researcher and can cooperate with each other, so they can share the code. Color is clear, understandable, easy to read, easy to maintain, and the same for developers. So develop it once and use it in many other scenarios. That's a high-level diagram how to Sentinel SDK build. That's in the center of the diagram. That's we have a processing unit. That's where all the logic of detection is handling, and that's left-hand side. That's our data sources. Here on this diagram, we can see that's three of them, like a Kafka, WebSocket, and file system. First two is more related to our hacking environment, Kafka for production, file system for more simulation. But we are not limited to using only these channels. There are could be much more. Amazon S3, Google Cloud Storage, ADLS v2, whatever you need. So that's just you need to build and develop a new channel which operate this with data source, and you are ready to go with consuming the data. And as I mentioned before, that detector is not just simple logic for processing the transactions. There is needed to have connection with already collected information from different databases, as monitored contracts, suspicious addresses, contracts, any other operation which we already store or we collect, or it could be a third-party system, local one or external one. It depends. And as a result of processing and detection, we need to have options for sending in case of, as we are talking about, working with extractor, that could be Kafka or HTTP endpoint for local simulation, for local development, for testing, for regression testing. We can use file system. All of these interfaces supported by default in SDK. So that's you can use. That's one of the way of not one of the way. That's a way of configuration detection. As it first on the top of the screen, that's a more metadata for detector, and the rest of the part input and outputs. That's an ID in our repository, which you can use for connecting. So instead of spending time for configuring different channels you can use existing one. And if we compare, for example, the configuration, this one more for production, the next one is for local. So the difference is that we have from left-hand side, that's production. And as you can see, this ID is referred to hacking cloud configuration, and the local one is just for local machine or local stuff. SDK provide several type of detectors. Most common used, that's a transaction detector. The main point is that since this detector process data in real time, main purpose to process data in real time, we have callback function on transaction, which triggered every single time when new transaction received from the channel. And just to compare how it's difficult to configure, you can see on the screen that's example of what you need to do. Just 4 lines of code, and the detector is ready, which support the different configuration. And now you can just continue, just describe this for 4 lines. You are ready to develop your detector and implement the logic. The second most popular detector is, or building detector, is block transaction. When comparing with previous one, when you received the only single transaction and working in frame of single transaction, this one more oriented to work with block of transactions. So if you can see this, we received already list of transaction. It's important when you need to have ordered transaction per block, when you minimal units of processing is just a whole block, whole information about all transaction. And if we talk about the transaction which we receive the part of this callback function, that's what I mentioned before. Unified transaction data model means that we are storing in this single message information from RPC messages. So we unite transaction block and transaction receipt, so in one message. So there is much more simplified the way how to operate with all this information, because you're receiving just one message and working with all data you need. The list of fields here is just as example, the most used fields. Another most used fields is information about logs. That's information about events happened during execution transaction. Most often that's interacting with a smart contract, this all information. And by default, SDK support more standard ERC20, ERC21 standards, and so on. That's what you can use. In example on the screen, you can see that how easy we can filter even transaction from the logs and extract and this information start to board. That's this time for integration with. So let's assume that we already implemented our logic based on transaction detector or block transaction detector, and we detect some issue incident that we need to report it to other system, or store it locally, or in case of integration with extractor, just to send it for notification. And that's an event class when you need just to, there is example when you need to just to fill basic fields which help extractor understand what is the field and what kind of type message we have. And metadata section, it's key value dictionary, which help you to add all information which you think useful for the user to know about such event. And this envelope can be used for sending all this information to extractor. and to be used for further monitoring and testing. Since we come close to the extractor, that's a way how we can how we can use it. First of all, what is extractor is? If you don't know, that's a security monitoring system. For the main goal is to perform real-time monitoring for your addresses. You can specify, you can configure it, and extractor itself contain already many existing detectors which developed and supported by Hacking, and which you can use for your case, but for your scenario. But since we are talking about the developing new ones, we can discuss the way how we can send the events, and there is a few ways. That's a Kafka endpoint and Kafka channel and HTTP endpoint. So from detector side, it doesn't really matter. So there is no changes for which channel you will use. That's only configuration, if you remember. So two types of configuration supported: static, which I already mentioned it before during that's what we do from configuration detector. Dynamic configuration, that's help us to make flexible configuration per detector. So it means you shouldn't restart detectors if you need to bring some. You can configure threshold or different parameters for each address. So create different detectors with specific cases. And to do this, in SDK provided you schema for detectors which you specified, and you register it in extractor. And as a result, you will have a user-friendly menu which help you to configure per address just to create detectors, create your monitor, configure these parameters which you specify especially for you. It could be for your logic of detection, and as a result, you can have you will receive if detection incident happen, you will have different messages depend on your configuration, depend on severity and report. Extractor support different also alerts, so it doesn't mean that you need to always be check the extractor UA. Extract can notify through email, HTTP, Telegram, or Slack message about incident, and recap. So for developing detector, we need to identify the patterns and the logic which we need to. We use Sentinel SDK to for detection, and configure extractor for consuming data, and we are done. We are ready to consume the data. So that's pretty much all from my side. That's thank you for your attention. Thank you. There is a contact if you are interesting. Feel free to contact me. And thank you one more time. And let's make Web3 a safer place together. Thanks.
Great. Thanks so much, Andrzej. Next up, we are going to hear from Antonio, who is the COO at Polyhedra, and we'll be talking about ZK Light Client for BSC.
Thank you. Can you hear me?
Yes.
Okay, cool, awesome. Hi, everyone. This is Antonio from Polyhedra Network. And today I'm bringing on a high-level overview of how we should deal with our challenge for this for the Q3 BNB Chain Hackathon. Well, I'm gonna start with an overview of what we provide. Then we will dive into the specific challenges a little bit hints on how you may want to come up with a solution. Then lastly, I will also show some of the help we may provide while you're trying to solve the challenge, and what you will be able to get and what experiences you will be getting during the time. So there you go. Basically, what we are providing is that we are providing a full stack ZK solution that empower interoperability and computation through our advanced zero-knowledge proof technology. And the graph you are seeing here would be the tool set that we will be providing to you during your during your development. And this is also the tool set that we are having. Specifically on the very bottom level, we have those wonderful protocols which are open sourced, and you can choose any of those, including Libra, Virgo, dVirgo, Pianist, Martin, Gemini, Orion. We have more to explore, which are all integrated in our expander compilation tool. So those are the protocols that are the world's most efficient ones, the fastest ones, and they have different advantages that you can freely explore, and that's the fundamental of polyhedral network. That's where we branch from. Then on the protocols, we build what we call a foundation for ZK products and applications. These include a ZK compiler, which I will present later. Then it includes Proof Cloud, which is a cloud service that help you to generate proofs and help you to cut your cost and help you to deploy provers just more easily. We also have hardware-friendly zero-knowledge proof algorithms, distributed zero-knowledge proof algorithms. We have ZKP for MPC, for FHE. Then we also provide GPU, FPGA, and ASIC acceleration. So with those foundation tools, you will be getting a good developer experiences building the applications. Then on top of our foundations are some of the applications we build out of our technology, which actually, you can build on your own. We're just building this to provide, some most needed services for our customers for Web3. Namely, one of them will be zero-knowledge interoperability protocol, which includes ZK Bridge and ZK Consensus Client, which actually is the topic of this hackathon session. And we also have, for example, zero-knowledge proof protocol for Web2 users, including banking services, including ZK ID services. We have ZKP for Bitcoin. We have ZK Oracle. We have AI integration and proof reserves. We have Ethereum ZK Consensus, and also layer 1, the ZKJ chain we are announcing soon. So these are the possible applications that you can also explore. And as developers, we also encourage you to build various applications, either based on the protocols we're providing or based on the foundation layer, the infrastructure that we're providing, or you can also build based on the applications here. Well, we call it applications because we are very deep in infrastructure. However, actually a lot of people will view our application also as part of the infrastructure. For example, ZK Bridge, it's more like an application or infrastructure. So, as developer, feel free to build on these. And now let's dive into the topic. So today the topic of the hackathon we are offering as a sponsored track is build a ZK Lite client for BNB chain. And this is one of the reasons why we need it. So in terms of cross-chain interoperability, well, not only cross-chain, but just cross-sector interoperability, one thing we need to do is that we need to verify the correctness of a blockchain. Well, namely here, since we are offering the BNB chain sponsor track, so one thing we need to do is to verify the block header of BNB chain, whether it's correct or not. There are multiple ways of doing it. Some other projects may use a more centralized approach, well, nodes delegation, etc., multi-party computing. But here at Polyhedra Network, we are providing a trustless way of doing this, which is through zero knowledge protocol. Because humans make mistakes, but maths won't. 1 + 1 will always equal to 2. So the most secure way of verifying the correctness of an execution of a blockchain would be using zero knowledge proof to verify the block header of it, as well as transactions, including block header. But just to simplify the problem that we are having for this hackathon, we are gonna verify the block header of a blockchain. And this is indeed partially of the infrastructure we implemented for ZK Bridge, which we have used to verify over 40 million transactions, 20 million transactions and 40 million proofs actually. So this is a very, very practical application. Then as long as we have this BNB chain updater verification ready, you will be able to verify it on all different blockchains. You can deploy that verifier on Ethereum, so you build a bridge from BNB chain to Ethereum. You deploy that on Solana, so you build a bridge from BNB chain to Solana. Since ZK is a universal language, as long as you have the ZK verification tool, then you'll find a smart contract engineer who could help you to convert that into on-chain smart contracts. You basically have ZK Bridge. Well, of course, a production level ZK Bridge will be a little more complicated since it involves all different transactions, different types of messages, and different chains, different consensus. But if we want to build just a one-way bridge from BNB chain to other, this will be a perfect example of how we should be doing it. And as we said, this is not only a cross-chain interoperability protocol. It is actually a more broader application other than only on the blockchain. If you have the power to build a verifier for BNB chain, you can actually use this in a lot of different scenarios because it can be verified on-chain. It can also be verified off-chain. And you can have your data on-chain. You can have your data off-chain. So the principles are the same. Essentially, this ZK verification toolkit provides with you the power of connecting any system from Web 2 to Web 3, from Web 3 to Web 3, from layer 1 to layer 2, or backwards, or anything you can think of. You can connect it with this ZK verifier. And most importantly, this is the most secure way ever in the industry to make this interoperability happen. Because Bridge is a major target for hackers, honestly. And security of Bridge is very, very important. And we believe that only zero knowledge proof can achieve the highest standards of security. And that's one of the reasons why we build Polyhedra, build ZK Bridge. And this is also the reason why we encourage every one of you to try it out, because this is going to be the ultimate solution of interoperability. Well, so now let's dive into what we are offering. So with building on this, we are also offering a cloud service, what we call Proof Cloud. So if Well, because proofs need machines to verify, and it's sometimes hard to get a good machine. So if you have any trouble of getting computational power on ZK verification, we help you with it. You can come to our Discord to apply to a trial on the Proof Cloud so that you can actually use a cloud machine to deploy and build your ZK circuits. Now, let's take a look of the exact topic, the exact challenge we're having here. So the challenge itself is called ZK Lite Client for BNB chain. Then in this challenge, you will need to use zero-knowledge proof to prove the correct execution of the verify header function. If you are familiar with the full nodes, with the consensus, you should be familiar with block headers and should be familiar with how block headers should get verified, the transaction hash, then the other parts that's included in the block header. So, well, you probably know how to verify the correctness of block header in, for example, full nodes. The challenge here we are having today is, given that we encourage you to use our expander compiler collection to build it out. So, well, the rewards we're offering as a sponsor track is the total rewards we're offering is 5,000 worth of US dollar. Then the first place winner is gonna get 3,000. The second place winner is gonna get 1,500, and third place winner will get 500 as rewards for this challenge. Then, a little more details on the goal. You will need to be able to prove the correctness of one BNB chain block header using expander by implementing your code in GNark and compiling it through the expander compiler collection. So we build the expander compiler collection with a GNark front end. If you are familiar with GNark, this should be actually a very simple task for you. Then the only thing you need to take a look at will be the expander compiler collection, which actually helps you to simplify the process of writing ZK circuits, like much simpler. Then as long as you get it, you will need to use that to write zero-knowledge proof to prove the correctness of any one BNB chain block header. We accept answers using any BNB chain block header, so you just need to do it once. Well, some of the documentation showing here you will be needing is one, the expander compiler collection documentation, which lets you know how you can install the compiler collection on your local machine, and also how to give some examples of how to run it. So if you're familiar with GNark, everything should be simple and very easy and very straightforward. If you're not that familiar with it, it's fine. We have very detailed documentation to guide you through what you should be doing. Well, and the second thing, you need to check the BNB chain consensus documentation, which, well, both of the links are uploaded on Dora Hack websites. You can find them. If you don't find them, you can also ask in our Discord server. We'll have our DevRel people helping you, guide you through the process. Then, because we are proving the correctness of BNB chain block headers, so you need to understand how the consensus works, which should be a simple deal for a lot of you things, since we have a bunch of BNB chain builders here. Then the submission. So what we are expecting from you would be one, a project description, how you achieve this, what tools you are using. Well, namely, you should be using expander compiler collection. Then you should write well-documented codes, including a technical documentation. You need to document your code. You need to explain your architecture and any other technical aspects you think that will be useful for our judges to look at. Then we will be expecting a simple demo video from you. Well, this is sometimes not required, but highly recommended. If you have a demo video that just makes things easier for the judges, and they will probably prioritize those who have a demo video, because it's just easier for them to understand. In the demo video, you can explain in language how you achieve this. You can talk about why you came up with this approach and how you were able to tackle it, and potentially any challenges you faced during the development. Then we do require source code. Since this is hackathon, then eventually the judges will need to take a look at your source code, the implementation of your project, to make sure first it is implemented correctly. Second, it's efficient enough to compete with other potential competitors that you are having, like other hackathon submissions. And also we will be able to run it locally to test it out. Just reminder, it should be a public repository on GitHub. Make sure you set it to public before you upload it. Then some submission links, including your GitHub repo link and a link to your project presentation, then a link to your demo video. So you will need to email these links. We'll later announce where you should email them as supplemental materials. Then lastly, a completion document, a document describing which components of the project you have finished, which are not. We accept partial submission. So as long as you have any progress, we encourage you to submit it. Then if you are partially done, you will get partial credits. Then, sometimes it happens that a complete project, but with very poor performance, may have lower score than a partial project with very, very good performance. So, just submit anything you have, and we encourage you to submit and discuss with us, and we are open for any submission. So, how the judges are judge the scores? So the judging criteria is as follows. The projects will be judged on one, performance. So how well does the project perform? Since we are having this hackathon, since we are a ZK company and we are providing this sponsor track in terms of ZK technology, and one important aspect of ZK technology is speed, efficiency, how efficient your algorithm is, and also how reliable your algorithm is. We are gonna run it against a lot of actually block headers to make sure that you are not hard coding anything, and also it should have stable performances against different block headers. This is one of the criteria because efficiency is very important in the field of ZK. If you are more efficient, then basically you are cheaper than others, you are more cost friendly, then it's just easier to deploy, and it's just more secure, and it'll be more stable. So if you have any ideas of optimizing the efficiency in your submission, please do. Efficiency will actually be a very, very important criteria for the judges. Then completeness. Are you completing all required features and functionalities? As we said, we encourage partial submission, but the more complete, the higher score you will get. We'll encourage you to try out every component of the challenge to make it as complete as possible. Then we have a bonus point, which is extension functionality. So if you have any additional features, please feel free to submit it with the project. For example, we talked about how this can be potentially utilized. Since this is a block header verification, then upon the completeness of the verification, what can you do? some ideas. You can do cross-chain products. You can do cross Web2, cross Web3 products. You can do products across layer 1, layer 2. And there are more applications. It can be a bridge. It can be a token bridge. It can be an NFT bridge. You can do message bridge just to send cross-chain messages. You can do potentially like, well, I don't know, SBT bridge, a DeFi bridge, just any information exchange. And well, this is a bonus point that we encourage you to come up with any potential applications we'll be having. You can just simply write some ideas you're having. If you're able to implement them out, that's gonna be wonderful. So this will be some extra bonus during your submission. If you feel you really enjoy the topic, we encourage you to try out the bonus credit so that it will help you to come higher in the rankings. All right, lastly, if you have any problem, please come to us. Please do not hesitate to ask us anything. If you need help, if you need machines to run it with, if you need potentially a walkthrough through the codes you're having, or any specific bugs you're having, or if any questions regarding the documentation of the Expander compiler collection, or documentation of BNB chain consensus, please do not hesitate to ask us. The major communication channel would be in Discord. Here's the link. We also post a link in Dora Hats so that you'll be able to find it. Then when you go to Discord, just ping any of the ambassadors or moderators or the admin so that they will help you to direct to specific technical support people. All right, so that's the challenge. Then the roadmap of Expander, of what we are building and what we will be having. So, well, honestly, we are still open. The team is open for anyone who wants to contribute, who wants to join us. You can either do through our public GitHub repo, or if you feel you are very confident in your submission, we can also invite you to the team. So this is Expander. We have a lot of things going on: CPU implementation, polynomial commitments, binary-friendly GKR, circuit compiler, witness generation, ZK bridge, ZK Light client integration. Well, that's done already. Then Expander Rust clone, which is also done. So if you feel you are interested in any of these fields, you can also come to us to say, hi, I would like to try it out. We have different teams of cryptographers in-house so that we can provide any insights, and we welcome any potential discussions to just let's make the world of ZK better. All right, so this is the proof cloud that if you feel you are in the need of extra computational power, if you feel you are in the need of potentially any machines that you do not have access to, but you want to test it out against your algorithm on either proof generation or other parts, feel free to contact us. We have this proof cloud working with Google Cloud to provide different computing power that you might need to have different machines here. And we also have some built-in ZK applications, ZK circuits that you may want to try it out. You can also check on some of the source codes to give you some inspiration on the implementation of the challenge. So as we said, we are always welcome to, if you need any help, we are always welcome in our Discord channel. You can always come to ask us any questions. And that will be it. I think I'm maybe 3 minutes earlier, and thank you.
Thanks a lot, Antonio.
Thank you.
We are hearing from Astro, who is the community manager at TUSD, about stablecoins and TUSD. Astro, over to you.
Okay. Hello, everyone. Can you guys hear me?
Yes, all good, thanks.
All right, so welcome to BNB Chain Hackathon 2024 Q3. My name is Astro, and it's my pleasure to conduct this workshop on stablecoins and everything about TrueUSD. Today, we will start with the fundamentals, stablecoin 101, TrueUSD use cases, and beyond. You guys will be able to understand what are stablecoins and what is TUSD. Then we will dive deeper into practical applications. What are stablecoin used for? What are TUSD's use cases? So now let's begin. So recently, stablecoins have often made the headlines due to their growing adoptions and bursts of various new stablecoins. But what are stablecoins? Let's begin with the fundamentals. Traditional cryptocurrencies like Bitcoin and Ethereum are well known for their extreme price volatility. They have dramatic increase, sudden crashes, and these fluctuations brings with them speculative investment opportunities. Stablecoins, on the other hand, are designed to maintain a stable value. As the name suggests, the most common method of achieving its stability, which is one used by TSD, is pegging the coin value to the US dollar at a 1-to-1 ratio. This creates a very high level of price stability. This stability allows stablecoins to serve as a reliable store of value and medium of exchange, making them suitable for various use cases, including everyday transactions in the physical world. To achieve price stability, different type of stablecoins employ different mechanisms. So uh, this is the usual way of classifying stablecoins. And understanding these categories can help us appreciate the diverse roles that stablecoin play in the broader crypto and financial ecosystems. Now let's start with the fiat collateralized stablecoins. These are backed by a reserve of fiat currencies, such as US dollars, held in a bank account. TUSD is an example of this type of stablecoin. We maintain a 1-to-1 peg with US dollar. This means for every TUSD in circulation, there is an equivalent amount of USD held in reserve, ensuring the value of TUSD remains stable. Next, we have crypto collateralized stablecoins. These stablecoins are backed by other cryptocurrencies such as Bitcoin or Ethereum. Because cryptocurrencies are volatile, these stablecoins are often over collateralized to observe price fluctuations. One example is MakerDAO's DAI stablecoin. It is pegged to US dollars but is backed by Ethereum and other cryptocurrencies. Then there are commodity collateralized stablecoins, which are backed by tangible assets like gold, oil, or other commodities. These stablecoins derive their value from the worth of the underlying assets. This also offers a way to invest in physical commodity through a digital medium. An example is Pax Gold, which is backed by physical gold stored in actual vaults. Lastly, we have algorithmic stablecoins, which might not be backed by any collateral. Instead, they use algorithms and smart contracts to control the supply of a stablecoin, increasing or decreasing as necessary to maintain a stable value. For example, when the price of the stablecoin rises above the target, new coins are issued to bring the price down. And when it falls below the target, coins are bought back or burned. One example of this is Athena's USDE stablecoin. Even among stablecoin, there is so much room for variations and specializations. Every stablecoin has its own use cases and unique development opportunities. Users should always select stablecoin based on their individual needs. Now let's explore the various use cases of stablecoin. There are diverse practical applications that have lead to their exploring opportunities. First off, daily transactions. One of the most straightforward applications of stablecoins is serve as a medium of exchange for everyday purchases. Unlike traditional cryptocurrencies, which can experience significant price fluctuations, stablecoins offer price stability. They provide a reliable and consistent method of paying, making them ideal for daily transactions, whether you are buying coffee or paying for services. Next, we have cross border payments. Traditional international money transfers can be slow and expensive, often involving with high fees and long processing times. Stablecoins simplify this process by enabling fast, low-cost transactions across borders. Remittance in particular benefit greatly from stablecoins as they offer a more efficient, cost-effective alternative to traditional remittance methods. Another important use case is decentralized finance or DeFi. In DeFi spaces, stablecoins can serve as a collateral assets for lending protocols. They can also serve as a medium of exchange in decentralized exchanges, especially as the base of a trading pair. Their stability makes them a preferred choice for those applications, ensuring that financial activities remains predictable and manageable. Stablecoins are also increasingly popular as a portfolio asset. As an asset with relatively high price stability, stablecoins can mitigate the risk of volatility in users' portfolios. This is crucial, especially during periods of market uncertainty, where stablecoins can reduce exposure to price volatility. Lastly, stablecoins are also increasingly being used in financial inclusion efforts. By providing a stablecoin and accessible digital currency, stablecoins can help individuals in underserved regions gain access to financial services. They can be a gateway for people without traditional banking infrastructure to participate in the global economy. But the story doesn't end here. The world of stablecoins is rapidly evolving, and there are emerging use cases yet to be fully explored. In our sponsors challenge in the previous quarter, we invited participants to consider the application of TSD in GameFi, SocialFi, Deepin, and AI. As we continue to innovate, stablecoins are sure to offer new opportunities and new possibilities, and transforming these even more aspects of our financial, digital, and physical lives. Now that we have explored the fundamentals of stablecoins and their use cases, let's dive a bit deeper into one particular stablecoin, TrueUSD. TUSD isn't just another stablecoin. It is first USD packed stablecoin that has live on-chain attestations by an independent third-party institution. This means that every single day, the integrity of TUSD and its reserve is verified repeatedly, assuring users of its reliability. TUSD has garnered widespread adoptions, being listed on over 80 cryptocurrency exchanges and DeFi protocols. This makes TUSD popular across the world and throughout the blockchain landscape. One thing that sets TUSD apart is its unwavering commitment to transparency and reliability. Every day, TUSD is attested by Merle HK, a global renowned accounting firm, providing an additional layer of assurance to its users. TUSD is also integrated with Chainlink's industry-leading proof of reserves, securing TUSD's minting process and verifying that all the TUSD in circulation is backed by real-world assets. So, how did TUSD become the pillar of stability and reliability that it is today? Here's an overview of the TUSD journey and the significant milestones throughout the years. The TUSD story started in 2018, where it was launched by TrueCoin LLC based in California. In March 2019, TUSD broke new ground by engaging Armonio LLP, becoming the first USD stablecoin with real-time attestations by independent auditors. With this milestone, TUSD set a new standard for transparency and accountability in crypto space. December 2020 was a pivotal moment when Textras acquired TUSD from TrueCoin. Fast forward to July 2023 when TUSD completed its international transitions. January this year, TSD partnered with auditing firm Moore HK to enhance its auditing practices. Receiving daily attestation services for its reserve assets, this partnership is another key step in TSD's continuing commitment to maintaining the highest standards of transparency and trust. Each milestone so far represents a chapter in TSD's journey. As we move forward, TSD will keep building upon these achievements, continuing to push the frontiers in crypto and DeFi. You might have noticed some common themes throughout TSD's journey. If you were to boil down TSD and its core features, they could be divided into three categories: popularity, trustworthiness, and liquidity. First, popularity. TSD offer convenience and utility in trading and transfers. Currently, TSD can be obtained on over 80 cryptocurrency exchanges and DeFi protocols. This provides users across the globe with flexibility and accessibility. The second core feature of TSD is trustworthiness. Of course, trust is the bedrock of any stablecoin, but TSD sets a new standard here. Advanced auditing and attestation mechanisms enhance the transparency of TSD. Daily audit reports are available on TSD website, allowing users to monitor the reserves at any time. In the fast-paced world of cryptocurrency trading, liquidity is paramount. TSD shines in this aspect, recording a daily trading volume over 1 billion US dollars in Q3 2023, underlying its impressive liquidity. Moreover, the TSD platform stands out by not changing or charging any fees or minting and redemption fees. In essence, these key features, popularity, trustworthiness, and liquidity, are at the heart of TSD's success. They form the fundamental pillar on which we continue to develop TSD. So far, we have spoken quite intensively about TSD's commitment to transparency. Let's take a closer look behind the scenes at the mechanism that enable this transparency. TSD has pioneered the practices of performing daily attestations by multiple independent third-party institutions. These attestations come in two forms, one being traditional auditing and the other being Chainlink's proof of reserves. These approaches provide a high level of transparency and is what sets TSD apart. On the left-hand side of the screen, you can see a sample of a daily attestation report, easily available for viewing and downloading on TSD's website. These reports are conducted by Moore HK, a global leading accounting firm. Each report presents verified information including token supply, escrow collateral, and collateral ratio. This provides a high level of transparency into the state of TSD's reserve, as well as its reserve breakdown. And on the right-hand side of the screen, you can see a sample data feed for TSD on Chainlink's proof of reserves. This data is publicly available on Chainlink's website. Using a decentralized network of oracles, Chainlink's proof of reserve fetches data from More Hong Kong, which performs regular reviews of TSD's escrow bank account. If the TSD's reserve in US dollar deviate beyond a predefined threshold, an update is pushed on-chain to the data feed. With these two methods of attestations, TSD is able to provide a very high level of transparency to its users. So that's pretty much about it, and thank you for your time. I hope this have given you some valuable insights into the stablecoin space for NTSD. If you find this interesting, be sure to follow us on Twitter. Best of luck with the hackathon. Okay, back to you, host.
Okay, and moving on to the last presentation of the day, we'll be hearing from Phoebe, who's community lead of BAS, on how to use attestation for different tracks. Phoebe?
Hi, everyone. Can anybody see the presentation slides?
Yeah, you're all good. Thank you.
Okay, great. Okay. Hi, everyone. I am Phoebe from BAS. First of all, very honored to be here to share BAS in today's workshop with fantastic developers, and thank BNB for inviting me. Today, on behalf of BAS, my presentation will mainly be split into 3 parts. First up, I'll give you the lowdown on BAS, its goals, significance, and vision. Then, in the second part, I'll walk developers through the basic concepts of BAS and how you can use it in your projects. This includes tips on integrating BAS seamlessly, so we will provide some real-world examples to share. Finally, in the last part, I will highlight some core potential uses for BAS, including possible applications across different tracks in this hackathon. Obviously, hopefully it sparks some fancy ideas for all you participants. So let's get started. So right now I want to introduce a little bit of what BAS has achieved so far. Right now, over 800,000 unique addresses have submitted more than 1.5 million attestations on BAS. More than 50 data sources have been integrated. These data sources including KYC information, sex trading data, LinkedIn, Uber, GitHub, social media accounts, on-chain reputation sources, etc. Obviously, we have over 14 partners have chosen to integrate with BAS to provide users with better and more convenient services. I want to share more details about the integration partners. We have been partnered with BNB domains with Space ID protocol, developer reputation verification with Aspecta ID, trusted data marketplace with Riddle, talents market reputation verification with Styro Market, Web3 social identity verification with Halo.social, and of course we have more partnerships on the attestation issuers. They are off-chain verification with ZiggyPass, Paddle Labs, Reclaim Protocol, and on-chain replication verification, Trust Labs, and Nomis. Going to the next slide. In this month, BAS collab with BNB official airdrop event as the only unofficial project for providing data verification. Ensure your Binance for 30-day trade volume is over 0 USDD. Users who qualify and maximize will have more chances of winning the rewards. You can learn more, about BAS and its core contributors on the official BNB chain documentation website here. And you can now find BAS on the official BNB chain website's developer page right here as well. The BNB attestation service is the first and only pioneering infrastructure in the BNB ecosystem designed to create attestations that verify information. With BAS, users can generate attestations, either public or private, for airdrops, reputation systems, trusted data transactions, and real-world applications, and so on. Blockchain's greatest strength lies in the standardizing asset issuance. Our goal is to bridge Web 2 and Web 3 by unifying data standards for Web 3 applications, all powered by BNB chain for sure. And going next, in our design, BAS will include the following 3 logic layers. At the base layer is the hybrid issuer, which can be any third-party resources such as Twitter, YouTube, Binance, or even any future project launched by developers themselves. This means that third-party issuers endorse their own attestations. And above this is the attestation logic layer, where we have designed 2 types of attestations. One is for public data, such as various public credentials or proofs of rights. The second type is for private data, which can be used in a DataFi model. Users can sell their private data to obtain data rights, and we also have designed a series of supporting data file systems for this purpose. Above the attestation logic layer is a specific application layer, which is the focus of the third module we will discuss today. We look forward to seeing various creative implementations on the top of our infrastructure. The next session is how BAS support BNB and Web3. The most direct thing is to help the ecosystem to do user segmentation, and this is also what we are doing right now to help the BNB ecosystem airdrop activities. Through verification activities, data is deposited in the ecosystem, empowering the next activity and ecological application. Currently, we have integrated with Binance KYC data, balance data, social media data, Steam data, GitHub data, and more. Another important topic is data standard. Based on BAS, we can build reputation systems, social fi, expanded DeFi, optimized governance, and enhanced data interoperability between different applications as well. To elaborate further, users can generate attestations of their data from different applications to build their own reputation proof. What you have and what you have done defines what you are, collecting all positions and behaviors fragments in different worlds to assemble a real you. BAS also introduced a new decentralized data trading model. The previous traded data consists of users' personal behavioral data, including social reputation, behavioral information, and so on. This new data trading model has proven its prospects in the traditional market, and its scale and potential are much larger compared to the traditional data trading market. This is because the ownership of traditional data is unclear, and the existence of data silos prevents the maximization of data value. Another important application of BAS is its support for the real world, such as decentralized identity, content verification, product anti-counterfeiting, and traceability, certificate and skill verification, relationship trust network, and data invoices. And after having a preliminary impression of BAS, we will use the BAS scan to briefly introduce various concepts involved in BAS, which will facilitate product design and usage for all developers. So for now, I may present you a short clip of video of real-time operation on our website. Is it sharing properly? Okay, I'm just gonna share it right now.
First, I will introduce the first important module in BAS, which is the schema. A schema is a structured framework that defining the data format and resolver with a test function. Schema dictate what kind of data can be attested and how that data should be presented. In this example, the data structure is designed to prove that a certain X account has more than 500 followers. We can see the composition of its data structure, where the most important parts are the hash of the X account's UID and a Boolean value indicating whether it has more than 500 followers. With such a data structure, we can determine whether this X account has indeed exceeded 500 followers. An attestation is an instance of this data structure. But wait, I don't know if you've realized a problem here. Anyone can submit an attestation for this schema. How do we determine whether the attestation is valid? This is where the resolver comes into play. Resolver. The simplest solution to the aforementioned problem is that we trust the certification from Twitter officials or a certain authoritative third party. Therefore, if the attestation is signed by a specific address, we can consider it valid. This step of verification can be placed in the attest function of the contract corresponding to the resolver address. Furthermore, more complex verification logic can be implemented in the resolver. Please note that anyone can create a similar schema, which also involves logic such as schema nesting and data reuse. The next concept is attestation. An attestation is a data with proof that can be used to verify the validity defined in schema. Attestation provide a standard for user to import any data into Web3. Within BAS, attestations can be created on-chain and off-chain. Users can store the off-chain attestations in Greenfield to provide the attestations access control. It includes some data structures, including an instance of a single schema, as well as information about who issued the attestation and to whom it was issued. As we mentioned earlier, the identity of the attester is often very important. Additionally, there is information such as the time when the attestation was issued and a verifiable transaction hash on the blockchain. Regarding attestations, I have one more point to mention. As we discussed earlier, we categorize attestations into two types: public attestations and private attestations. A public attestation, like the one you are seeing now, has all its information stored on the blockchain and can be viewed by anyone. On the other hand, a private attestation is implemented using Greenfield. Through Greenfield's permission control, we can manage access to private attestations. I believe this is a significant advantage of building an attestation system on the BNB chain. We can leverage Greenfield to achieve some fantastic goals, such as our ultimate objective, DataFi. For more details about BAS technology, you can refer to the documentation available on our website. You can follow the guidance there to create your own schema and attestations step by step. This includes the use of our SDKs, which we provide for both JavaScript and Go developers. Additionally, I want to emphasize that I strongly recommend developers to understand the mechanism of delegate attestations tutorial/delegate attestation. This could be a common pattern for business development using BAS, especially in scenarios where users need to pay gas fees. In such cases, the project party only issues the attestation, and the user is responsible for submitting it to the blockchain.
Okay, that's the end of our short clip. Now we're back to the slides. So after sharing that, our next our focus is on providing participants with ideas for different tracks. Of course, we hope that everyone will come up with even more outstanding designs and ideas, jointly build the attestation ecosystem on BNB chain. Firstly, in a gaming track, by adjusting its infrastructure to meet the specific demands of gaming logic and economics, BNB chain is not just keeping up with the current trend of blockchain gaming, but also shaping the future landscape. Highlighting its commitment to leading the way in this dynamic sector, BAS will play a crucial role or stand in this process. Through BAS, player identity verification can be achieved by developing a tool that allows individuals to make cryptographic attestations, proving that they are unique human beings, and using biometric information while ensuring their data privacy. Achievement systems or leaderboards within games can also be implemented through BAS, benefiting game developers who can use the system to reward experienced players. And another important system is the in-game item trading system, which can serve as the infrastructure for GameFi. This data can achieve security and tradability through BAS. Of course, with sufficient and well-developed ideas and designs, I believe these systems can be implemented in a unified manner and complement each other. Once this system is established, it will play a very important role in the future GameFi ecosystem, and I look forward to seeing your works. The second track we want to take as an example today is the social track. The social track has always been one of the hot topics in Web3. BNB chain and BAS are dedicated to revolutionize the social networks through the use of blockchain technology. A decentralized social network should be a crypto-native platform that supports various social features such as social graphs, messaging, live streaming, and content sharing. You can use VAS as a base layer for social graphs to enable the creation of truly decentralized and interoperable social networks. Attestation provides a way for users to securely and selectively share their data with others while retaining control over their own personal information. You can design a unique schema to define the relationships between users or even implement social layering. And another simple but important application is KYC. Building a base layer for attestations will allow different organizations and services to provide attestations about different aspects of a person's life, such as education, work history, and other credentials. We have already provided some KYC examples on our website, such as the KYC system for Binance, actually. These specific applications can be aggregated to do more interesting things, such as reputation system. I believe that there is no very good solution for an on-chain reputation system yet. However, with BAS, attestations about trust scores and relative experiences can be recorded on BNB chain or off-chain in Greenfield, providing a secure and tamper-proof record of reputation. All attestations issued to an address can form the reputation score of that address with BAS, and the potential applications in this direction are vast. I believe that once a BAS-based reputation system is implemented, it will bring significant improvements to the current on-chain financial system. The third one I'll be sharing is the payment track. We know that BNB chain provides a comprehensive solution to build a dedicated payment layer 2. Further optimize user experience, BAS can offer numerous assistance to the payment ecosystem on BNB chain. One direct example is transaction receipts. BAS can provide immutable transaction receipts that offer additional contexts, allowing both parties to verify them independently. By transferring offline payment records to the blockchain, through this method, users can redeem rights and interests on the chain. Similarly, using BAS can implement an on-chain invoice system to verify an invoice and confirm timely payments, thereby establishing the creditworthiness of specific addresses. In this case, an invoice or receipt is an attestation, which is verified by the merchant issuing it. When making payments, many people often encounter the need to verify the identity of other party. Therefore, a merchant verification system can be built based on BAS to enhance buyer confidence by verifying a merchant's credentials, transaction history, or customer satisfaction ratings. This is applicable to identify verification for C2C merchants. Similarly, merchants sometimes need to verify certain information about users, such as in the refund system, you can use BAS to create a system where refunds and returns are attested, ensuring all parties acknowledge and agree on the order status. As a cornerstone infrastructure in the BNB ecosystem, BAS has been coming a long way and is designed to generate attestations that securely verify information. We hope this presentation sparks innovative ideas among all participants, and we look forward to seeing new ideas emerge and inspire potential applications across the various tracks in this hackathon. If you want to know more details about BAS, follow us on X, join our community for the newest updates. Thank you everyone for listening to us.
Thanks, Phoebe. And thank you everyone for joining. And just a reminder that submission will end on August 15th. So there's still time to submit your entries. And as always, keep updated on the official BNB Chain social channels. And just another thanks to our speakers who joined us today as well. And have a great day and see you next time. Thanks.